Hi, welcome back to the channel. In our last lesson, we saw equation of a straight line. In case you missed that lesson, we'll place a link in the description below for that lesson. In this lesson, we'll see equations of parallel and perpendicular lines. We'll see the conditions for parallel and perpendicular lines, and then we'll use worked examples to help you understand it better. That said, let's get into class. Hi, welcome back. Like I said, we would look at the conditions for these parallel and perpendicular lines. Let's get started with the parallel lines. Two lines are said to be parallel when both of them move in the same direction, and clearly both of them would never meet. Now, the basic condition for parallel lines is that the gradient or the slope is equal to each other. That is, m1, if the slope of the first one is m1, is equal to the slope of the second one, m2. This also implies that m1 over m2 is equals to 1. Whichever way you understand it, it's just the same thing. Now let's use this example. The example says a line is parallel to the line 6x, is parallel to this line 6x plus 3y minus 2 equals 0, and it passes through this point 0 and 3. Work out the equation of the line. The first thing is to express this line in the standard format for equation of a straight line. That is y is equals to mx plus c. Now, so that my 6x plus 3 minus 2 will become 3y will be the same thing as minus 6x plus 2. I've moved 6x to the other side and minus 2 to the other side. So that y now will be the same thing as minus 6x plus 2 over 3 over 3. Y now will be the same thing as minus 6x over 3, that's minus 2x plus 2 over 3. When compared this to y is equals to mx plus c, obviously my m in this case is the same thing as minus 2. Now, since the lines are parallel, if m for this line is minus 2 and it's parallel to the line we're actually looking for, that means my m2, which is the line we're looking for, also will be the same thing as what? Minus 2. And it passes through this point. So let's get ahead to solve for the equation. M is the same thing as minus 2, and it passes through the point of 0 and 3. Now, we know that M is the same thing as y2 minus y1 over x2 minus x1. Now, in this case, my y2 will be the unknown y, x2 will be the unknown x, and my x1 and y1 will be this value. So that my m is minus 2 will be the same thing as y minus 3 over x minus 0. So that minus 2 obviously is the same thing as y minus 3 over x. If you cross multiply, minus 2x will be the same thing as y minus 3. So that if I rearrange it, my y obviously will be the same thing as minus 2x plus. Now, clearly, I can interpret this line, this y is equals to mx plus c. The gradient of this line is minus 2, and the intercept on the y-axis will be 3. Now, let's see for perpendicular lines. Now, two lines are actually perpendicular when they cross each other at 90 degrees. That is, there's a 90 degrees cross between them. But the condition for the perpendicular line states that m1, m2 will be the same thing as minus 1. That is, if I multiply the scope of each of them by each other, I should get minus 1. Or m1 will be the same thing as minus 1 over m2. Now let's get to it. This example says that we should find the equation of the line that passes through the points 3 and 4 and is perpendicular to the line 4x minus 6y plus 7 equals 0. And let's put it in our standard format. My minus 6y will be the same thing as minus 4x minus 7. So that y now will be the same thing as minus 4x over minus 6 minus 7 over minus 6. Minus cancels minus. 2 here is 2. 2 here is 3. So that my y obviously is the same thing as 2 over 3 plus 7 plus 6. This minus definitely cancels this again to become positive. Here's x, sorry, here's x. Now if you compare it with our standard equation, y is equals to mx plus c, we'll be saying that our m in this case also is the same as 2 over 3. Now let's take this as m1. So we'll look for the second m2. And let's remember that it passes through which points? 3 and 4. Passes through this point 3, 4. X will be equals to 3, y will be equals to. Now our m1 was 2 over 3, and we're told it passes through the points 3 and 4. So that my m1, m2, remember, will be equals to minus 1 because it's a perpendicular line. So that my m2 now, this is 2 over 3, m2 is equals to minus 1. My m2 will be the same thing as minus 1 times 3 over 2. My m2 obviously is minus 3 over 2. Now remember that m we say is the same thing as y2 minus y1 over x2 minus x1. So that's minus 3 over 2 will be the same thing as y now minus, here will be my y1, 4 all over x minus 3. Let's cross multiply. So I have minus 3 into x minus 3 now equals 2 into y minus 4. Invariably, my minus 3x on opening the bracket here will become plus 9 equals 2y minus 8. Let's collect like terms, or let's regroup our values so that my minus 3x plus 9 minus 8 is equals to 2y. Minus 3x plus 1, oh, this is plus 8, sorry, not minus 8. If minus 8 crosses this side, it becomes positive. Plus 17 is equals to 2y. Let's divide both sides by 2. Divide this by 2. Divide this by 2. So that's my minus 3 over 2x plus 17 over 2 will be equals to y. So once again, we've seen that our gradient has come back to minus 3 over 2, like what we actually used here. And the intercept on y-axis is 17 over 2. With this, I hope you understand how to construct equations for straight, for perpendicular, and parallel lines. Thank you for staying with us and see you in our next class.